member of Board of Directors in F-Secure. Please give a big hand to Christine.
Thank you, Piotr. So, hi everyone. I hope lunch was good. It's great to be here, actually. And before I begin, I have a confession. I've never been to any Python before today. In fact, when Piotr asked me if I could speak not only at a Python conference, but the Python conference, I thought the message belonged to Steve. I was like, what was I supposed to say that would be interesting to these people? And then he told me that I could talk about threats. And now, digital threats, that's my bread and butter, so I said yes. And then I realized afterwards that it's probably a trap because now I have a task of linking Python with digital threats. But that aside, why do I like to talk about malware, digital threats, cybersecurity? Topics that apparently are so hip and sexy nowadays. Well, this is because my background is malware analyst. So when I started in the early 2000s, I was analyzing malware, creating cleanup tools, reverse engineering, and then creating disinfections. And I was doing this for several years until the amount of malware started escalating. And so did the need to automate. So I finally got my stint as a developer for 2 years. And I was building a honey client system. So this was a system where I had a vulnerable browser, and it was automatically visiting the internet. And when there's a drive-by download or exploitation happening, then we gather the results and then send it up for detection. And I was enjoying building this honey client system. And I was using a cool language called, no, it wasn't Python. It was Perl, and I used Perl because I was already heavily using Perl-style regular expressions in my job, and it seemed natural for me to just continue and use Perl. And this romance that I had with regular expressions ran so deep that they became the characteristic of my code base. 1 second, yes. I seem to have forgotten my slides. There you go. There's always something wrong. All right, where was I? So I was talking about the romance that I had with regular expressions that became the characteristic of my code base. And don't even get me started on that code base because there was one time that I was looking for a bug. And it was only after less than 6 months that I wrote the code. And then I came to the conclusion that my code, it was like a pack of diapers. Now, you can make your own conclusion what that means, but for me, I thought that it was time to make a change. So I was planning to refactor my code and change the programming language when my application for F-Secure went through, and I got accepted. And so I became a malware analyst once again. Now, why am I here when the only time I mentioned Python was that I didn't use Python? Bear with me. In this story, we are still currently in 2008. And 2008 was a time when the web as an infection vector started escalating. So as a malware analyst, I not only need to analyze malware, I needed to build scripts to help me with my job. And so I used Perl for this because I was used to it. And then eventually, somebody asked me if I could share my code. And then, like this. Okay. So somebody, oh, this is louder. So somebody finally asked me if I could share my code, and then when they looked at it, it became a matter of whether they trusted me enough to execute it. Eventually, somebody told me that F-Skill was a Python house, and that if I could convert my code into Python, then it would be better. So I have to admit, I was suspicious of this Python thingy at the very beginning because they didn't have support for my favorite Perl-style regular expressions. What do you know, it did. It was quite straightforward, actually. So after I managed to let go of my semicolon line endings, the rest, as they say, is history. So I was a convert, and Python has become my official go-to scripting language. Even up to today, when I'm already managing people and growing white hairs in the process. So there are parts of my old technical job that I couldn't quite let go. So I'm still doing that, and I'm still using Python for that. But there are new things that I'm discovering, like this concept of micromanagement, where I could apparently interface with our repository's API and figure out if my people are actually working. I'm just messing with you. I don't actually do micromanagement. At least I hope I don't. I have one guy here. I hope he says that I don't. But that aside, what I really mean to say is that to be a Python coder, one doesn't have to be an expert coder. And this is why in cybersecurity, we are one of the industries that have benefited heavily from Python. And today we're going to look at the different points in time, the different milestones in the cybersecurity industry. Beginning with the very first malware called Brain. Do you really expect me to go back to the 1980s and talk about Brain? I hope not. But if you are interested to know about Brain, you can fire up your favorite search engine and check it out later after the presentation. And there's a very good presentation from a man that I'm proud to call my colleague, Mikko Hyppönen. You can check it out afterwards. But for today, let's start somewhere a little bit recent. Around 15 years ago, when file infectors were still present, mass mailing worms were having a field day, and network propagating worms, they were grounding aircraft and stopping trains. So let's begin, shall we? File infectors. So file infectors was the characteristic of the very first types of malware. And they are the reason why the terms viruses came about. Because what a file infector does is, it looks for a host file that it can try to attach itself into. Now, there are many different types of infection, and one of the most common ones is the appending infection. There are also sneakier ways of infecting, such as when the virus looks for a file that has different empty spaces in between, and then it will split itself into pieces and attach itself into those spaces. Now, viruses were very effective during the time when people were sharing files mostly via floppy disks, USB drives, network shares. And propagation continues because the person who you're sharing the infected file with will execute it. So all that the virus had to do is try to figure out interesting files that people would be sharing. Now, what your antivirus needs to do during this time is to remove the infection from the file, preferably without corrupting the file. And as a malware analyst, you would now need to understand how the virus infected the file in the first place. So, as an analyst, you need tools. And one of these tools that we use is a debugger or a disassembler. And one of the very first, most popular actually, disassembler in the reverse engineering community is the interactive disassembler, or IDA. Now, reverse engineering, this is a tedious task. So if you have a rudimentary disassembler, you don't have any other tools maybe, you would have to trace the code line by line, step into it, create breakpoints, label it so that you don't forget what are the routines that are happening there, until eventually you finish the code, or you figure out what you're looking for. And depending on the complexity of the malware, if it's obfuscating its code, or depending on the size of the malware, this could take time. So in 2005, one colleague of mine who was working in F-Security then called Gergo, whose real name I cannot pronounce, so let me pronounce it. He invented Python. And Python helped us automate a lot of these processes. Python helped us automate the obfuscation. And Python got so popular in the reverse engineering community that in the next versions of they actually released this together with Now, for example, here is a disassembly of the banking Trojan Emotet. And this is how it looks like the moment you load it to a disassembler with nothing else that you did. Now, as a malware analyst, when I look at this, I have no clue what it's trying to do because it's not exposing any APIs at all. So what Emotet did is that it's trying to hide the Win32 API function names so that it will take time to reverse engineer this. So as an analyst, you would know how to trace it line by line and try to figure out the code. Time is of the essence when it comes to malware detection. So the longer your malware is out there in the wild, the more chance it has to do damage, and the more profits you can potentially gain. So any hurdle that the attacker can put on an analyst's path will benefit him in the long run. So this is why they do this. But with a little Python knowledge, some EDA knowledge, the analyst could now automatically figure out what this API function calls are. And EDA is actually not the only disassembler that has Python support. There are many others out there that have them as well. So, for example, the Immunity Debugger, there's the GNU Debugger for Linux, there's WinDBG for Windows, and even Radare 2, which is open source. So nowadays, it doesn't matter if you have the money to fork out on a more expensive disassembler or would opt for open source ones. Chances are they all have Python support. And it makes reverse engineering a little less tedious. So still, early 2000s, people were not always online as we often are nowadays. There is a concept of going online. And when people go online, typically what they do is they check their emails. So the attackers know this and they're trying to figure out a way to exploit this behavior. So this is the time that they introduced mass mailing worms. There was a very popular worm around that time called Love Letter, or the I Love You virus. And what it did was it's propagated by your emails, and then it retrieved the contact information of the target whenever the script was executed, and then it forwarded itself further to them. Social engineering was very much at work here because, can you imagine, receiving an email from a girl or a boy that you were pining for, and then it has a subject, I love you, and then an attachment called love letter. Would you open it? Suffice to say, this tactic was very effective because globally the estimated damages caused by love letter was more than $1 billion. Now, this time, the cybersecurity industry had to build spam traps so that they can trap basically these emails. And then we started building sandboxes as well so that we can extract the attachments and execute them in a sandbox and then automatically gather what events happened during the execution. After a few months that we did this, malware, the attackers, began to realize that there is this sandboxing thing happening. So they started trying to identify if they are executing in a sandbox. And if they are, they terminate themselves without any events happening. So it makes our job a little tougher. So this is why most sandboxes actually are proprietary, so that malware is unable to identify if it's executing it. But if you are an organization and you would not like to start from scratch, you would like to start from somewhere, there's a very good sandbox called Cuckoo, which is actually Python-based. And VirusTotal, which is currently now owned by Google and has a conglomeration of different scanning engines, also uses Cuckoo as their sandbox. Now, even today, we are still using sandboxes because ransomware is heavily spreading via emails. And they're coming in as email attachments. So we had to extract the attachments and execute them in a sandbox and basically gather the events that happened during the execution. Speaking of ransomware, who among you here have heard of WannaCry? All right, that's a very good number. So WannaCry, as many of you already know, is a network worm that spreads via the SMB vulnerability. And this spreads from one machine to another without user intervention. Now, in the cybersecurity industry, this is a reminder of us of the network worms of early 2000s, where when they started spreading, it was pretty much DEFCON 1 in the cybersecurity industry. So it's all hands on deck. We don't go home. Shift manager orders pizza for us. And then we hope that there's not going to be any earthquake because we're not going down the building anytime soon. So it was pretty much everyone needed to be on board. There was a very popular worm around that time called Blaster. And Blaster was affecting the networks of hundreds of organizations globally. If you can imagine the network bandwidth during that time compared to today, it was significantly lesser. So we have way more juice in our networks nowadays. And one of those organizations that was affected was Air Canada. Now, Air Canada's network got so clogged that it left little for the normal business functions to continue. So they eventually had to shut down, clean it up, and patch the vulnerability so that they can bring their network back up again. And while they shut down their networks, they also had to ground their aircraft. Another network worm that followed was Sasser. So Sasser affected the Windows service that is in charge of logins. And as a side effect, Windows started shutting down. Now, this shutting down effect was so disruptive that it caused ticketing systems of different trains globally to be started shutting down, the machines that were printing tickets. So since there's no tickets being printed, trains don't leave the station. So they were stopping trains. And as notorious as Blaster and Sasser may be, there's also one threat that's rising during that time, which are the bots that were connecting to command and control servers. And they were also spreading via these network vulnerabilities. I remember a time when I was in Taiwan, and I think there was a time that I got myself my very first laptop. I was so excited. And then I went online, and the moment I connected, I got 3 bots. Just like that. Welcome to the internet. 3 bots for you. So this aggressive spread that they did by the cybersecurity industry think that we needed to get this malware before they end up on our users' machines. And so we started building honeypots. So these are low interaction honeypots that typically have vulnerable services that are exposed to the internet. And there's already a few honeypots that were created during that time, but the very first one with Python support was Dionea from the Honeynet project. And even today, Dionea is still used by some organizations. After a while, the honeypots become more specific. So they are now targeted towards specific services. And the ones that I'm listing here are actually all Python-based. There's more Python-based honeypots where this came from. But there are some notable ones like Honeypress, which is only for WordPress, or RDPY, which is for RDP and is implemented by a twisted Python, whichever. Few more years have passed and internet became cheaper, so people were staying online a little bit longer. And at this time, malware has now less need to become fully self-contained. So what this means is that if previously you got a full banking Trojan in one email, what you would get now is a downloader that has a predefined URL where it will download the banking Trojan from. So malware started modularizing. And so we began to be introduced to the concept of malicious URLs, malicious domains, infected websites. And the nasty thing about these malicious URLs is that their content can change. So the cybersecurity industry began to realize that file-based detections, they were no longer enough. And so we started to build URL reputation systems. And we started to hire more developers. And in the case of F-Security, we started to hire more Python developers. And you can imagine these URL reputation systems that in our backend, there's a database of hundreds of millions of reputations. And then we have front-end servers that are delivering these reputations to our users. But in between this is the glue that drives it all. So there are honey clients, there are metadata extractors, there's APIs, there's tools, there's systems that are generating the reputations and giving the ratings to the users. And I mentioned earlier that I built a honey client system, a proprietary honey client system for my previous employer. But what I didn't mention was that there's actually open source honey clients out there as well that are even written in Python. So for example, there's the very first honey client that was created by the HoneyNet project, once again, called Phonicy. They released this in 2009. In 2011, they replaced this with Thug. And Thug now is using a headless browser. And Thug is actually quite good. It's still in heavy use by different organizations, even up to today. And then I mentioned metadata extractors. So how our metadata extractors work is that there's specific to certain file types extractors of data. For example, PDF. We have PDF or PDF tools, and these are all written in Python and open source. And then for portable executables, we also have PE file, which is also Python and open source. Few more years, exploits have now become exploit kits. But there's also something that the bad guys were trying to do. They started specializing their operations. So if previously there was one guy who was trying to propagate his malware, distribute everything, build his malware, etc., this time there was one group, so it's no longer like one guy. There's one group trying to infect websites, another group building exploit kits, and still another group building payloads such as ransomware and banking trojans. And they were so specialized and quite effective in their craft that, for example, if there is a news website that you visited every day, the same site that you always go to, and for some reason last night it got infected. So today you visited the same news site, and then it redirected you into another website instead. And this new website was actually a landing page for an exploit kit. And what an exploit kit now would do is that it will probe your browser for vulnerabilities, one after another. And if it doesn't work, then it will probe your browser extensions for vulnerabilities. So the extensions that you have for Java, for Flash, for Silverlight. And then when it finds a vulnerability that it can exploit, then it will deliver a payload to your system. And typically around this time, the payloads were either ransomware or banking trojans. So just by visiting the same website around this time, you could be infected. And so there was so much of this infection actually happening that our developers were telling us that our SQL-based databases were getting obsolete. And so they were thinking that we needed to replace them because they couldn't handle the amount of writes that we were doing anymore. So they started researching into these non-SQL databases, and we ended up with Cassandra. And as a Python house, our thrift driver was PyCassa. And then next stage was also to reconsider how we do automation, because our previous ways of automating, they also did not work very well anymore. So we started looking into artificial intelligence, specifically machine learning. And the very first things that we used was support vector machines, and this is via scikit-learn. And then we also started hiring data scientists in our ranks because they were better at mathematics than the rest of us. And this metadata that I'm talking about, this massive amount of metadata, this is not just happening for one cybersecurity organization like F-Security. This is happening to other organizations as well. But in the cybersecurity industry, we realized early on that it is only through working together, it is only through collaboration that we are able to effectively combat cybercrime. So this collaboration, it's not alien to the industry. Ever since the very beginning, we have already been sharing samples, sharing malicious URLs, and trying to protect our collective customers. But since this sharing is from different databases in different locations globally, sharing is a little bit clunky. So the malware information sharing platform changed that. By this time, we are now able to share indicators of compromise. So these are file hashes, registry entries, malicious URLs that would tell an organization that an infection is happening. And for Python houses, there's a very good interface for the MISP API called PyMISP. Finally, now we're in 2010. So 2010. 2010 was the time when the cybersecurity industry was shocked to discover Stuxnet. Stuxnet was a malware that tried to attack the uranium enrichment facility of Iran. So it destroyed centrifuges while telling the dashboards that everything was fine. Now, the sophistication of this malware, the cost that seemingly went into it, and the discovery of who the target was, made us realize that not only was government-sponsored malware real, but they were the most advanced that we have ever seen. And so organizations started having the need to profile their attackers in order to understand if the same attacker is attacking them with a different malware, or if the same attacker is attacking a different organization. And so there are very good tools that enable us to properly organize our analysis, such as Viper, which is Python-based, open source, and is a binary analysis and management framework. And in a world of advanced persistent threats, or APTs, or targeted attacks, attacks have become multi-stage. So at the very beginning, no malware may be used. And it could just be a series of tools that on their own may look innocent. But one after the other, if they are used in a certain sequence of events, could lead to the infiltration of an organization. And when the attackers get in, so when the organization gets infiltrated, an organization that has actually tried to protect themselves could have sensors. And these sensors are typically licensed from cybersecurity companies. And what they do is like they harvest anomalies from systems, from the network, and they upstream them to the security provider's cloud or backend, where there are threat hunters, the responders that are looking at this information and trying to figure out if there's an attack happening, if there's something that shouldn't be happening in the network. And if they find these anomalies, then they will give the organization a call and inform them that a breach is happening. This is the time when we are now building products such as endpoint detection and response. And whenever we build products, we build test automation as well, because we need to automatically test these products so that they are production grade. And our test automation in F-Secure speaks Python. After the attack, now it's time to reflect, try to understand how did the attacker get into the organization in the first place? Which path did they take? What are the weaknesses that actually were there so that they managed to get in? What can we do so that we can prevent the same event from happening again? And this is the time when forensics come into play. Now, unlike defense, forensics has a lot of open source tools out there. And this is just a fraction of what is available. So for example, there's Linux Explorer, Python, and open source, and or for Linux endpoints, there's volatility for extracting RAM artifacts, etc. But when we say forensics and defense, we have already come to the conclusion that the attacker has already entered the organization. Do we have something that prevents the attacker from entering the organization in the first place? And we do. We also perform attack simulations. And these are commonly known as penetration testing or red teaming, where a group of security consultants actually try to infiltrate the organization, figure out its weaknesses. And then they will create a report saying that these are your weaknesses and these are our recommendations for you to fix them. And penetration testing has a lot of both open source and proprietary tools available, from the very expensive to the free ones. Some of those are listed here. Notable ones are, for example, the Metasploit framework, which started as Perl, and then eventually they changed it to Ruby. And then they realized that apparently cybersecurity researchers are better at Python than Ruby. So they added support for Python modules. And even Meterpreter, which is Metasploit's advanced payload, supports Python. There's also Cobalt Strike. So Cobalt Strike is the type of tool that you use if you want to do a team-based penetration testing. And Cobalt Strike also has scripted web delivery that supports Python. And then there's KP, which is open source purely in Python and is used to manipulate network packets, etc. These tools, though, that you see here, yes, they are used by security consultants and researchers, but they can be used by the attackers as well. So they are heavily dependent on the motive of the user. But there are also times when Python was used purely for malicious purposes. There was one advanced APT. So what it did was that it's called APT28, and it had several Python scripts. And some of the Python scripts were scanning IP ranges. And then the other Python scripts were connecting to command and control servers. Online, especially in GitHub, you can actually find also Python malware. And some of those are even recent ones like ransomware. There are also remote administration tools or post-exploitation tools that you can see there. This particular one looked interesting to me because it's not every day that I see pictures in GitHub. So I took this one up. And it's a remote administration tool for Macs, which is also a post-exploitation tool, and it was only pretty much doing damage. But what's interesting is that it's not really hiding its intentions. It's a picture of an evil-looking rat. We have now seen different ways of propagating for the past 15 years. And the old methods, they still work, like social engineering. Because can you imagine if you have a job opening in your website, and then somebody pretended to apply to that job, and then added an attachment called the resume.pdf. And then they sent this to your HR department. Do you think they would open it? So those things, they do still work because of this intrinsic trust that we typically place on our fellow human beings. But there are also new methods that the attackers have come up with. In this globalized world where different organizations are connected by the different software that we license from each other, we purchase from each other, poisoning the source meant that everyone who is connected to the same source could be affected downstream. And last year, we have seen one of the biggest collateral damages in the history of supply chain attacks. NotPetya was a malware that spread via the same vulnerability that WannaCry used. So it did that to spread laterally. But before it did that, it was first used, distributed, as an update to the MIDOC accounting software. Now, this is a software that organizations who do business in Ukraine use. And they use this to compute their taxes. Now, NotPetya got its name because it was pretending to be Petya, which was a very popular ransomware around that time. And like Petya, it was encrypting files and the master boot record of the machine. But unlike Petya, instead of encrypting the master boot record, it corrupted it instead. Now, we can only speculate whether this was intentional or if this was a developer's mistake, but it cost Maersk a very expensive headache. Maersk is a global logistics company, and they do business in Ukraine. And by virtue of doing business in Ukraine, they use the MEDOC accounting software. And when they updated the MEDOC accounting software before they patched the SMB vulnerability, these worms spread like wildfire in their organization. It caused so much damage that they ended up in almost a $300 million bill. Now you may say that, well, it doesn't really affect me. My organization doesn't do business in Ukraine. I have nothing to do with Ukraine. And for the case of NotPetya, yeah, that may be true. But I don't know if I even need to ask if people here use the PyPI repository. If you need a package, you pip install it. Python is convenient that way. And this is why last year, malicious packages were uploaded to the PyPI repository. And this included a package called urllib. Now, if you, at the time, when those malicious packages were there, did a pip install urllib, instead of perhaps specifically really pointing to urllib3, well, you would have gotten everything that urllib3 had, plus a little extra, which is a piece of code that connected to a remote location. Now, thankfully, that was all it did, so this was still proof of concept. But can you imagine if it changed the functions instead, such that as a developer, it will still do what you expected this function to do, but maybe add a little extra, like open up this machine that the script is running to the outside world, effectively creating a backdoor. As long as the dark side of humanity still exists, and as long as we use any form of computers, digital threats will continue to exist. And you have already seen, threats are opportunistic. First, they will try to find the cheapest ways to infect you. But if the payday is worth it, even if it's difficult, they will still keep trying. As a computer science major, I find it hard to find a more satisfying job than protecting not only people's information, but in this world that is increasingly online 24/7, their lives as well. So if you, as a Pythonista, feel that you're interested in cybersecurity, but maybe sometimes you feel like you may not have anything to contribute, let me tell you now, we have plenty of room for you. We have room for people who are passionate in Python, and room for people who are passionate in cybersecurity, and especially room for people who can combine them both. So, the next time you want to make a change, remember this moment. Thank you.
Thank you, Christine. Now we have some questions. The first one is, do you debug things through IDA, or do you prefer other tools like X64, DBG, or any others?
All right, so I'm going to start revealing my age, I guess. Well, the first debugger that I used was Soft Eyes. Nobody has probably heard of Soft Eyes. Problem with Soft Eyes is that it like totally hang the system, so you're like debugging the whole system. Next debugger was OnlyDBG. Maybe a few people have heard of those? Yes, sometimes still used. There are moments that it doesn't really sort of give the advantage that IDA has. But yes, I've used IDA, and of the three, IDA is actually my favorite because there's also too many extra plugins that I could use. But X64 DBG, I haven't used it. So, yeah. Next, oh,
Do you work on malware for Linux or macOS? Do you use GDB to pound BG / Jeff?
I haven't debugged any Mac OS X, but I've debugged Linux ELF, and yes, the GNU debugger was useful. But on DBG, haven't tried this one. Hope that answers the question.
Do you use 1Password, LastPass or similar? Is it secure and worth to pay for it?
This is a password manager?
Yes.
Okay, so advertisement coming up, because F-Secure has our own password manager, so I actually use F-Security. So, because I'm from F-Secure, but it's a good one. Advertisement ends.
Do you have sticker on your computer camera?
Of course I do. But it's actually not a sticker, but it's this like sliding thingy. Yeah. I'm paranoid, come on.
Does it make any sense to use third-party antivirus malware software over that provided by OS vendors?
You guys are not making this easy on me. Well, it depends. So if you are actually trying to really protect yourself through the last 1%, because if you look at results of these external testing organizations like A/B tests or A/B comparators, the differences between different antivirus products is the last 1%. And, well, of course, F-Secure got best protection for like so many years in a row. Advertisement ends. And the thing with Microsoft Defender is it has actually been catching up as well. So they're already at the stage when they are actually very good. But still, there's the last 1%, where, for example, products that are paid use, such as behavior detection. And this behavior detection are not file specific and they are not URL-based detections. They are basically hooking different APIs in the system and seeing if a sequence of APIs is used, then this is potentially a malware infection. So a bunch of heuristics are being used. So if you want those for malware that has not even been found yet, then I would suggest you opt for a more paid, maybe, software offering. So all in all, it's really up to you, like how secure, how much of this last 1%, like the last mile of malware, do you want to get?
Which OS do you use?
I'm using Windows at the moment. I use Linux as well for my, what do you call it? The machine where I analyze malware, because most of the malware is in Windows, so that if I unfortunately double click it, then it wouldn't work. There's that.
What was the most dangerous malware that you encountered during the whole career?
Oh, it's a good one. There was a very old malware around early 2000s, and I was still training to become an antivirus engineer. It was called Chernobyl or CIH, and the machines during that time, it was flashing the, what do you call this, the BIOS, flashing the BIOS of the machine such that it's black. When I turn it on, it's black. And then I go back to my instructor around that time. It's like, my machine is black. Of course it's black. This machine flashes the BIOS and you can't do anything with the machine anymore. So that was like a physical danger to the machine. So it was, I think at the time, it was the most dangerous. I don't see much of those today because like for the BIOS today, they are more resilient to this type of attacks.
Have you ever written your own virus?
No. Even if I did, I would never tell you. I'm going to get fired. But no.
Have you watched Mr. Robot? If so, did you like it?
To be honest, I only watched like I think 2 episodes. It was a bit driving at the beginning. If you can assure me that it gets more exciting, then I might continue. Does it get more exciting? Okay, then I will continue. I'll hold you to that.
Did you hear about Veles?
No, I haven't. I haven't.
I would like to learn how to efficiently reverse engineer network APIs used in Android ARM apps. Where should I start? Which tools may help?
EDA actually supports ARM. The last time I actually looked at ARM, I'm going to be very old here, was when I was reverse engineering Symbian, so I haven't really reverse engineered Android, but EDA has very good ARM support. So I would suggest that, for example, if you're a student, you can get an EDA license that is not really as expensive as what the professionals use. Yes?
If you want to reverse engineer the network APIs, you should also use some kind of proxy, like network proxy, like Proxy or something like this, so that you can see what the requests are being done.
Listen to the guy, knows his network APIs.
How exactly machine learning used in the threat detection? What kind of data does it use? How efficient is it?
It depends. So machine learning is very useful when it comes to malicious websites. And for example, we have metadata like who is information, we have metadata like what is the DOM of this structure. We have metadata such as what is the entropy of the code here, because malware typically likes to obfuscate its code. Presence of certain calls to JavaScript, for example, eval, escape, unescape, and then this information. So we extract them and try to experiment building different models to see if they are actually effective and how many percent. So when it comes to the industry, when you say precision versus recall, we are really very biased on precision because a false positive is actually quite dangerous for our users. For example, if we false positive on a Google website, then our users will no longer be able to use that website because it will be blocked. So even if there's very low recall, as long as the precision is very high, like I would say 99 point something percent, then yes, we do use those. But we experiment with different types of models, especially for malicious websites.
Okay. What antivirus software do you use?
Security, yeah.
What do you think about such an antivirus software like Kaspersky, which should protect us, but is probably working like a malware spy company?
Come on, I love Kaspersky. Like I would say that Kaspersky Antivirus is one of the best out there. They're quite innovative. They always advance their products. Now, I cannot say if you're a spy for a certain Western European country if you should use Kaspersky. But typically, in the industry, we kind of like Kaspersky. It's a very innovative, and it's actually a very good antivirus. So I think Kaspersky is.
What's your theory about Stuxnet? Who made it?
You guys are making it hard. Well, the conclusion was that of the cybersecurity industry was the US and Israel. So that was the conclusion.
Which mobile OS is safer?
What do you mean by this question? Like, safer in the sense of you don't get spied on, privacy, or you don't get malware? Because it's both Google and Apple, and they do upstream a lot of your data, so I can't really say from a privacy perspective which one is safer for you. But malware-wise, Apple is very strict when it comes to signing these files, and probably iOS developers here know in the room that how many times sometimes your app gets sent back because it violated this and that, and then sent back again because the next stage you violated it. So Apple is actually more strict than Google when it comes to that.
And you have security updates for a long time.
Sorry?
You have security updates for a long time. You have your 4-year or 5-year-old phone, and you still have security updates, which is not true for Android device.
Yes, that is true. But eventually, though, Apple also stops supporting old hardware, so there is that. But in general, I would say Apple is slightly more strict, and this strictness actually leads to a more secure ecosystem.
I think we have 3 minutes left, so a few more questions.
Okay.
Have you been ever hacked?
Not that I know of. I'm kind of paranoid, but you'll never know until you know.
Will people stop writing malware viruses someday?
Honestly, I don't think so. So it's like asking if will people stop doing crime someday? So, I mean, if we don't want to do crime anymore, then maybe we'll stop writing malware. But nowadays, the motivation for malware is money. And sometimes it's easy money. So people do it for the cash.
Do you use proprietary software on your personal laptop? And don't you think that it's naive to use things you know nothing about?
I have some certain level of trust, I guess, in some organizations. But yes, if you really want to be like really paranoid, sure, every time you execute a software, you can monitor what it does to your system. But, well, I don't know how you're going to live like that. I mean, there's probably very little software you can install in your machine.
But you're that part of you write your own operating system, because it starts with operating system.
You could write your own operating system, yes. It's going to take a while, but yeah, you could, of course.
Are you playing any CTF?
Not recently, so I'm old and I'm like managing a lot of people at the moment, and I'm not really playing CTFs anymore.
Okay. That was done. Can we think about Google Antivirus system as a malware software with self-spread our private data?
This is actually funny. Like maybe more than 5 years ago, when it comes to software that is just sucking and upstreaming data, we started thinking that is this a spyware? Because we previously had a concept of spyware. The funny thing is nowadays, we don't have spyware detections anymore. Go figure. Has it become accepted? I don't know.
Does encrypting your drive protects you from ransomware?
Well, if you encrypted your drive and then ransomware encrypted your drive, so you still have to reverse the encryption of your drive so you can't go back to the original encryption. So essentially, ransomware would still affect you the moment you booted up your drive. Because ransomware will infect when you are, like for example in Windows, when you have booted up and ransomware is executed on this machine. So yeah, it will still.
Which application to disk encryption you consider the safest, I mean hardest to decrypt by third person?
I haven't really evaluated different disk encryptions. I'm using BitLocker, and at the moment, it seems to be enough, at least. So like when my hard drive is turned off, at least nobody can just mount it somewhere and then read the contents of it. So that's the protection that I needed.
What's your opinion on using the same tools like disassemblers, debuggers, and hex editors to bypass proprietary software licensing or disabling tracking?
Bypassing licenses, come on guys, that's bad. But yeah, people do use it, but I don't really recommend it because of the ethics behind it. So, but when it comes to privacy, well, you can do pretty much what you guys would need to protect yourselves.
And the last question, how can I be infected just by entering a website without executing any download, etc.?
So this happens because of browser exploitation. So when a browser is exploited, just like any vulnerability, typically when you go to a website and then there's an executable, it will prompt you saying that you want to download, execute this, blah, blah, blah. But when a browser is exploited or a browser plugin, then this is bypassed. So it goes straight to your machine. So this is why this can happen, because of a vulnerability.
Okay, thank you very much, Christine.